Hi, my name's Steve from Hortic Developments. I teach the RHS Level 2 certificate in the Principles of Plant Growth, Propagation and Development. And this is the second taster video that we've done, this time covering Unit R2102, Plant Nutrition and the Root Environment. And the aim behind this taster video is just to give you a flavour of the teaching videos that I've created for this particular unit, and hopefully then to give you the confidence to purchase this unit's teaching materials and help you complete the course and get ready for the exams. Enjoy. So how do we practically determine what type of soil that we have in our gardens? That's going to be the most useful way of applying it to ourselves, or if we're working maybe in a client's garden. So when we look at the average soil, it's not going to be purely clay, it's not going to be purely sand, and it's not going to be purely silt. There are going to be elements, I'd have thought, of a lot of different types of soil. So we have what we refer to as the soil texture triangle. And what it means is that gives us a view of how we can determine what aspects of clay, silt and sand make up the soil that we're looking at. So the best way to do it, and it's a really simple process, really easy to do, is to do a soil jar test. So you grab yourself a clear jar. This is one that I did for my garden here. I'll just run through the process and then we can quickly analyse what that jar is telling us. So you take your jar, a reasonable jam jar or an old coffee jar, something like that, and you put your handful of soil in from wherever you want it in the garden. And I would suggest when you're taking that to dig down a little bit deeper. Don't just take the surface soil, but just go down a few more centimetres and get a good trowelful, drop it in the jar, and whatever amount of soil sample that you put in there, top it up with twice the quantity of water. Then put the lid on the jar, give it a really good shake and aerate it for 5 minutes or so, and then set the jar aside to stand perhaps overnight. And what will happen is that will settle. You'll start to see the soil settle down into its different layers, and you'll see a distinct layer there. So here, the heaviest one, your biggest particle size is down the bottom here, is sand. And then in the middle, you've got your silt, and then at the top, you've got your clay. So you can see my soil isn't particularly clay. It's only that thin layer right at the top. I've got a reasonable amount of silt, and then I've got a lot of sand in my garden. So the next thing you do is you're going to measure the thickness of each band. So measure the entire length of the soil. So you've almost got a mini horizon here that you're looking at with its different layers. So measure the entire length of the total soil sample, then measure each layer accordingly. So you should be able to see a clear distinction between each one as it's settled. So just spin the jar around till you find the clearest levels there and measure each one. So you're going to have a thickness for your proportion of clay and silt and sand, and you're going to take each layer's measurement and you can divide it into the total, so the total depth of the soil, and then you're going to multiply it by 100, and that's going to give you your percentage. And what it means is you can take those percentages and apply it to the texture triangle here. And you can apply that one, and then whatever your percentages are, you then look where they all meet up on the chart, and that will tell you what type of soil that you have. So it's worth giving that a go, and do it from maybe a couple of points throughout the garden just to see you're getting a clear reading. And it's a quick and easy method to work out what your soil type is like. Okay, so let's think about what we should be adding into the compost heap to get the best results. Now we tend to break it down into two colours, and two colours is the easiest way to remember. We have what we refer to as brown waste, and we have what we refer to as green waste. We'll get into the technicalities of what these actually are in a moment, but just to understand, and it always helps to remember it this way, and then you'll decide, then it'll help you decide what's going into the compost heap. The browns then are any plant material that is brown in colour, and that includes autumn leaves, dried out grass, wood products like wood chippings and bark chippings. That also includes paper, straw, things like that. Those are all what we call carbon rich products that we're going to add to our compost, and you can see a longer list there in that first box. The greens in contrast then are, green. It includes fresh grass clippings, freshly picked weeds, and plant clippings that we've had from prunings and things that we've taken down in the garden. And also we've got some things like vegetable scraps and fruit scraps that we can add out of the kitchen as well. And what we're looking at now is how these two products work together. The reason we've divided these up into brown and green, you'll see on our next slide. So how does the plant tell us if it's not got enough nutrients? Well, it displays what we call nutrient deficiencies. So the plant will show us that it's not happy and it's lacking in a particular nutrient. If a plant fails to thrive, if a plant is not doing very well, despite we have done all the correct things that we should do in terms of helping it to grow, then there may be the signs of a nutrient deficiency. So if we have a plant and we know that that the plant we've put into the ground has had adequate soil preparation, we've cultivated the ground well, it's ready to go, we've incorporated any organic matter that we need to. If we have watered that plant in well and continue to keep up a watering regime if it needs it, and if we perhaps mulch the plant as well, so we've put that mulch around the surface of the plant, it's helping to preserve the moisture, control the temperature that's going on around the root system, and also some of those nutrients are feeding back into the root system. If we are still seeing signs that the plant isn't happy, then we may well have signs of a nutrient deficiency. And particularly fruit and vegetables are vulnerable to this, as are plants that are in containers as well. So if you can think about it, fruit and vegetables are going to use up vast quantities of nutrients whilst they're getting to that point where the fruit is going to ripen. And if you think about the plants that are in containers, and we're going to go into this in a bit more detail in a future session, the plants in containers are going to use up the nutrients in that environment very quickly as well. And what will happen is we will start to see the plant, particularly in the leaves, tell us that it's not happy and it needs more nutrients. And it'll even go as far as to tell us what nutrients we should be giving it. Very clever, the biology of plants. So we've looked at that, and it may think to yourself, well, what on earth has that got to do with gardening and the gardener? Why is it important that we understand how pH works within the soil? The first thing we have to remember is that all soils will have a pH value. And to contrast that, all plants will have a pH preference. So we're looking at bringing the two together, finding plants that are appropriate to the soil pH levels, that are happy in those particular levels. So below 7 on the pH scale is acidic, above 7 is alkaline, as we can see there in the middle there. So that between that 6 and that 7. So the easiest way to remember is that most plants are going to be happy with soils very slightly on the acidic side, so around about that 6.5, sitting nicely between the 6 and the 7. Plants can be found though in soils ranging between 4 to 8. Anything outside of those numbers, you'll find that most of the plants will not be happy in those environments. So even the more acidic or alkaline preferring plants won't get much beyond that 4 or that 8 on the scale. So let's think about how the water progresses. So let's start at that first point when we are watering a container. So as we apply the water to that container with that plant that's growing in there, all the pores, remember all those spaces that are in the compost, are going to be filled with water. And as that water comes down through the pot, it's pushing the air out of the pores and it's replacing that air as it works its way very slowly down through the root system, and it's giving an opportunity then for the roots then to be able to absorb a little bit of the water as it comes through. It should be enough that it's not draining too quickly and it's not draining too slowly, and that's what's great. You've got more control when you're using a compost or a growing medium inside the actual pot itself. So what we want then is that the water has somewhere, the excess water has somewhere to escape, and this can be through a drainage that we've created at the bottom of the container, whether that's holes in the container. Most containers should come with holes. They'll often have points where you can drill them out to make sure that they're there. And then what I would do is move them up onto little pot feet or to some bricks so that you've got as well an area for the water to very clearly flow away, so you're not letting the roots of the plant sit too much in the water. So then that drainage continues and you get what we call a wet profile that's moving down through the compost, whilst then as that, if you can remember, as that happens, as the water moves through the compost, air is then going to come back into those pore spaces at the top of the container. So there's that constant relationship between the oxygen and the water taking place as we move down the container. When drainage stops, it's because the lower part of the mix remains saturated in water. So there comes a point where either the water isn't moving any further, because it could be that the compost is well compacted and there isn't enough movement to allow the water to escape, or it means that there isn't adequate drainage at the bottom of the container. Saturation, remember, is determined by the pore sizes of the mix, which is determined by the particle size or the texture. That's how it all works together, remember. Remember, cast your mind back to when we looked about the principles of pore spaces and what's taking place in the soils. That's exactly the same principles that are happening here with the compost. Those pore sizes are very clearly defined when we choose the different mixes of compost that we're going to put in the container, and we'll look at that in a lot more detail a little bit later on. So there is a range of compost that is called our seed compost, and it's designed to germinate seeds, and especially small seeds as opposed to larger seeds, and sometimes people will also kind of root some cuttings in there as well. So again, it's traditionally quite a light compost that the new plants can start to germinate, that they can push their roots out into as they start to emerge. So as the germination of the seed takes place, and we'll go into this in a future unit, you'll find that it's got to push its way from the soil depth that you've planted it at. It's got to push out the root first to give it some stability. It's then got to push its leaves up to the surface so it can get to the photosynthesis stage, and this compost is designed to do that. And some of it will come with something called vermiculite, which again we'll go into in a little bit more detail, which is a naturally occurring mineral that aids the moisture retention as well as insulates the seeds against temperature fluctuations and humidity changes. So you'll find that there are things that you can add to the compost to aid the germination process that's taking place. The other thing as well, it's characteristically a lot lower in its nutrient contents, because the seeds don't need the nutrients at that stage, but it's enough just to keep the seedlings going. So the seed, as it germinates, is going to have most of the nutrients it needs to make a start, and then it'll just have a few others that it can kind of just pick up as it gets itself started, but it doesn't need that much in the way of nutrients to start with. If you enjoyed what you watched and are interested in purchasing the rest of the videos that go in the full unit, then please click on the link to purchase those videos, and we will get you organized with all that it entails. Not only does it contain the video lessons, but you'll also get copies of these presentation in a PDF form so you can make notes on it. I'll also send you some flashcards with key information to help you revise for the exams, and we'll also pass on some past RHS exam papers to help you revise as well. If you've got any questions or queries, don't hesitate to get in touch with me. My email address there is stephen.ensel@gmail.com. Many thanks.